My name is Shashank Shekhar, and today's chapter is some basic concepts of chemistry. This is the first chapter of the 11th class. So let us start our today's chapter. So if I talk, first of all, we will start with the importance of chemistry. So we know that chemistry plays a central role in science, and we can see that it intervenes with various branches of science and explains various phenomena occurring around us. So whether we talk about the weather patterns or about the functioning of brains, or we talk about operation of a computer, production in chemical industries, manufacturing fertilizers, alkalis, acids, salts, dyes, polymers, drugs, soaps, detergents, metals, alloys. So including all of this, including new material, they are the outcome of chemistry. Now chemistry also contributes in a bigger way to national economy. It plays a central role in meeting human needs for food. So example, if you want to say grow a crop, you would require to grow it well without any say interference of any insects or pests. So for that you use insecticides and pesticides. Then we have healthcare products and other material that are aimed at improving the quality of life. So if we talk about examples as I said, we have fertilizer, pesticides and insecticides. Next, it provides method for the isolation of life-saving drugs from natural resources and makes possible synthesis of such drugs. So for example are cisplatin and taxol. So cisplatin in use in cancer treatment, which are effective in cancer therapy. So they both are important in cancer therapy. So in the recent year, chemistry has helped in dealing with some of the pressing aspects of environmental degradation. So we know that the refrigerators that are present in our homes or the AC, they release CFCs, which is called as chlorofluorocarbons, and they are responsible for ozone depletion in the stratosphere. Now, where chemistry has helped to synthesize a safer alternative to this environmentally hazardous cooling reagents, that is CFCs. Okay. Next is the problem of greenhouse gases. So we know that this greenhouse gases is something as we have the earth has a phenomena, means a phenomena is going on earth always, that is called greenhouse effect. So the greenhouse effects allows the heat to come to your environment, but it does not allows it to escape your environment. So the gases which are helpful, which are responsible for these effects, are methane and carbon dioxide. Next, for understanding biochemical processes, the use of enzyme on large production of chemical and synthesis of new exotic material are some of the intellectual changes for the future generation of chemists. To be a good chemist and to accept such challenges, one need to understand the basis concepts of chemistry, which begin with the concept of matter. So for all of this, we start with some basic concepts, the concept of matter. So the definition that we have learned from the starting is that what is matter? Matter is something that has space, that has mass and that occupies space. So if you take any matter such as book, so you can have book. Now book will have some mass. If you try to lift it, you will face some resistance in lifting it. In addition to that, it will occupy a cuboid space. Similarly, if you take a pen, it will also have a mass, although it is less than the book, but it will still have a mass. Now if you take that pen, then it will occupy a cylindrical space. Similar to that, we have pencil, water, air, and all living beings. Yes, they are all composed of matter. Okay. Next, if I talk about the classification of matter, so matter can exist in three different physical states. First is solid, liquid, and gas. Now the constituent particle of matter in these three states are represented in shown in figure. You can see the figure here. So this is the arrangement that is found in solids. This is the arrangement that is present in liquid, and this is for gas. So the three physical states of matter. Now we talk about, so if you see all around you, you can see each states of matter. So suppose you are sitting on a table on a chair. So that is the example of your solid. Then the water you drink, that is the example of liquid. And the air you breathe, whether the air you breathe or the air you give out, that is oxygen and carbon dioxide, they all are air. Although you cannot see air, but they are say they give us a sensation. So whenever a wind blows, you can feel a sensation of cooling. That sensation of cooling or say hotness, that depends upon the nature of gas that you are being hit with. So that sensation is given by the gas. Now particles are held very close to each other in case of solids in orderly fashion, and there is not much freedom of movement. So if you see here, in this, then this is solid. So in this solid, what happens? The particles are very close to each other. Okay, the particles are very close to each other as the force of attraction between each particle is very high, and they are held together tightly. So this is the case of solid. Now if I talk about liquid, the force of attraction is very less, so the particle can move freely here and there as compared to solid. Then we have gas, in which the force of attraction is least, and here the particle can move so freely that whatever space we keep those gas in, it will occupy the whole space. So we can say that in gases the particles are far apart as compared to those present in solids or liquid state, and their movement is very easy and fast. Now if I talk about the characteristics of matter, so solid have different shape and different volume. So how we can say it? For example, you take a cube. Okay, you take a cube or say you take a dice. So when we play Ludo, we put the dice in a so I'm talking about the physical Ludo that we used to play, not the visual one. So whenever we play Ludo, we take a container, we keep the Ludo dice in it and shake it and then throw it. Now if you observe there, when you put that cuboid dice in that cylindrical bottle, then it does not fills the container completely. Okay, and you can think of very few examples where you can completely fit that space that is being provided to the solid. Where in case of, if you take a case of liquid and if you fill it, then most of the space means it will cover the whole of the container if you pour enough water into it. But that is not the case for solid. You can take another example of solid. Suppose you take sand and you start filling sand into a tub. Okay, but due to the interatomic distance between the particle of sand, you will see that there is much space that is left out after the filling of sand, where in case of liquid that space is less, and in case of gas that space is least. So why is it so? What is the reason behind it? The reason behind it is that solids had different volume. So into whenever you keep a solid into a mug, then it does not changes its shape according to the mug, and there's some space left after filling the mug. Now if I talk about liquid, they completely fill it, but they cannot leave the surface because there is some force of attraction. They all will stick together. But if I talk about gas, they do not stick at all. They move freely, and they completely occupy the system which you have given. Okay, next, liquid have a different volume, but they do not have a definite shape. As I've told you, that liquid have different volume because they can stick together. So if you take one glass of liquid, one tumbler, suppose you are taking 1 liter of a liquid, whether you keep it in any container, that will always remain 1 liter, but the shape will change. So if you take it from a mug and keep it in a tube, then it will take the shape of cube. If you keep it in a tub, it will take the shape of tub. So it will change shape according to your container in which you are keeping it. Okay. Now if I talk about gas, they do not have definite volume or definite shape. So the by shape, you understand that if you keep again in different container, it will take the shape of the container. But what about this volume? Why this is not definite? So suppose you are taking gas and keeping it in a cylinder, right? Now suppose that gas leaks out of the leaks out of that cylinder in a room. Now that gas will occupy the whole room volume. Okay, it will move freely and will occupy the whole volume. So initially, suppose the volume of the cylinder was 1 liter, and now you have filled it in a room. Now the room, suppose, is of 2 meter, says the 2 to the 4 to the 6 meter cube, then 8 meter cube, suppose. Then now the same amount of gas which was only filling one cylindrical container, or you can say cylinder, is now filling the complete room. So the volume is changing. So therefore the volume changes of gas. So they completely occupy the space in the container in which they are placed. Clear? Now what about the states of matter are interconvertible? So how can we see it? So the very best example would be if I take ice, which is the solid form of your water. Now if I heat it, then the water will slowly start melting and convert it in and get converts into liquid. The liquid, say water, that you drink or that you use. Now again, if you heat it further, that same liquid will convert into gas. While if you travel the converse way, so if you start cooling your gas, then it will be converted into liquid, and that liquid will convert into solid. So the same thing is written here, that on heating a liquid, a solid usually changes to a liquid, then a liquid on further heating changes to a gas. But in the reversible process, a gas on cooling liquefies to a liquid, and the liquid on further cooling freezes to a solid. Clear? Now if you want to see an more clear example that how on cooling gas converts into liquid, so suppose you take a tumbler of glass, okay, that is filled with water, cold water, very cold water. Now the surface of that tumbler is very cool. Now water vapor is present in the environment. Okay. Now you will see after some time that the outer surface of your tumbler is say filled with droplets of water. Why is it so? So what happens here, that the outside air that is present, that is containing water vapor, when it heats your tumbler, heat means that strikes your tumbler, then the cooling effect of the tumbler cools down your water vapor and converts it into liquid that is deposited on the surface of the tumbler. So that is the cooling of gas to liquid. Now again, if you keep that liquid in a refrigerator, that will further cool down at 0 degrees Celsius. It will be converted into ice. Got it? So this is the direct phenomena. Now what is the reason this conversion is taking place? Why the heat converts the solid into liquid and this liquid into gas? So the reason behind it is kinetic energy. Okay. So whenever you take a solid, the solid particles are held together by interatomic forces. Now the interatomic forces, the magnitude of the interatomic forces remains same when this solid converts into liquid. Okay. and it remains also same when this is converted into a gas. Suppose I filled it with a liquid. Yeah. Now the magnitude of the force is same between the molecules of the atom. Then why is this change in the state? So the reason is the kinetic energy. So you must have heard this kinetic energy. It is there in the physics. Okay. So what is needed for the particle to move? That is your kinetic energy is needed. Okay. So due to kinetic energy, it utilizes kinetic energy to move here and there freely. Now where does this kinetic energy comes from? So this is coming from heating. This is called thermal energy. So it is basically the conservation of energy. So whenever we supply heat, that energy goes into your molecules of solid, and they break the intermolecular forces between the solid, and now they can move freely. Now if we supply further heat, this particles leave the surface, means they neutralizes neutralize the force that is being provided by the atoms and move freely here and there. So we can say that kinetic energy of solid is least. Then we have kinetic energy of liquid. Then we have the kinetic energy of gas. Okay, clear? Now, one more point is that the solid particle exerts the least pressure on your surface container in which it is kept. Suppose this is kept in a surface like this. This is your container. Okay. Now, why the pressure exerted by the solid is least on the container, then it is in the midcore for liquid and most for the gas. Why is it so? So, if you remember, pressure is nothing but force per unit area. We know this definition. Force per unit area means the force that is applied in a unit area. Now, how we can apply force? So, if something is moving and pressurizing it, suppose this particle is here, it is fixed. Now it is not colliding with the walls of the container. But if we move to liquid which has a higher kinetic energy, due to higher kinetic energy, it moves faster. Okay, it moves faster. Now it strikes the surface of the container at a faster rate. Now on striking, it applies force. So that is the force. Okay, it is the force that is being applied upon the movement of this particle. Now as we move to gas, whose particles move more freely, means they have higher kinetic energy, so they are moving faster. Okay, now when they will collide with each other or with the wall of say container, so when they will collide with the wall of container, they will exert again force. Now that force will be greater in case of gas, greatest. So we can say that pressure, I am representing pressure with P of gas is more. Then comes the pressure of liquid. And then comes the pressure of gas. Okay, clear? So these are the 2 points you should remember. Now, say how we can say that your particles of gas are moving freely, not your liquid one. So for that, how you can feel it? So I have told you earlier that if you just open the lid of the gas, not your normal gas cylinder I am talking about. Suppose we have helium gas, or say we have your perfume. Okay, that perfume is contained in a container. Now if you spray it, even if you spray it on your body, the nearby people can smell it. Why? Because the aroma or the smell is present in the form of gas. Okay, that aroma or that smell is present in the form of gas. Now, since the gas particle can move very fastly, so it reaches very quickly to your nose. So if its velocity is high, So therefore its kinetic energy will be high, because we know that kinetic energy is equals to half mv square, where v is the velocity. So if velocity is more, therefore kinetic energy is more. Similarly, if your mom is cooking food, if your mother is cooking food, then you will quickly get the aroma of the food, that what is being cooked. Okay, so you can say that its velocity is very great, and that would be due to this reason its kinetic energy will be high. Got it? So let us try to quantify it on a table for solid, liquid and gas. So say we have solid, we have liquid and we have gas. If I talk about intermolecular forces, molecular forces, so intermolecular forces is high, so here it is high, medium and least. Then we talk about kinetic energy of particles, low, medium, high, pressure on container in which it is kept, low, medium, high. Next, if we talk about volume, so solid have a definite volume. It also has a definite volume, indefinite. We talk about shape, it is definite, indefinite, and this is also indefinite. Okay, so these are some main points you should remember about solid, liquids and gas. So this is the first classification of matter on the basis of state. Now if I ask you that whether your glass, the glass which is there on your window, whether it is a solid or liquid or gas. What is a solid? What is a glass? First attempt, most of you would say that glass is a or glass is a solid. But let me make it clear, it is partially true. It is partially true. How can we say that it is partially true? What is the reason behind it? So for that, if you want to observe that whether it is solid, liquid and gas, then you can observe a glass panel that must have been installed on your home or in any other place. Now if you look at the bottom of that glass panel, so suppose this is your glass panel, so it must be jointed some place to the to the window, okay, to the frame. Now if I look at the bottom of that frame, then you will see that the glass is thin in between and thick at the bottom. Okay, so what is the reason behind it? The reason behind it is that glass is not a solid, it is a pseudo liquid. It is pseudo solid, I would say, not pseudo liquid. It is a pseudo solid, meaning that it means that although it looks like a solid, all of its behavior is that of a solid, but it is not a fully solid. It is a pseudo solid. You can say it is kind of liquid. So you can imagine, so if you take water and just put one drop of water on the wall, then you will see that the water is slowly flows down. So similar to that, the glass particles also flows down and get coagulated at the bottom. So that is the reason they are thicker on the bottom side. Clear? So we can say that glass is not purely a solid, it is a pseudo solid, or you can say super cooled liquid. Now if I ask you what is the density comparison of all these three states, that is solid, liquid and gas, at first glance, if you look at your diagram that is being given here of the liquid, of the solid and liquid and gas, at the first glance you will say that since the particles are very close to each other, therefore its density should be high. In case of solid, means solid should have the highest density, then liquid, then gas. But the case is not as simple as this. So for that you have to observe a very simple phenomena. So if you take an ice, which is nothing but a solid form of liquid, and if you keep it on the water, you will see that the solid floats. And if something have to float on something, then its density should be high. What do you mean by this, that density should be high or low? So it means that uh, suppose you take a surface of table. Okay, density is high means the particles are very close to each other, right? Now if density is high, then the particles, the external particles will not be allowed to pass through it. Okay, similarly if you take ice and keep it on water, then you will see that the solid is not going inside the water, it is remaining at the surface. Okay, now I will give a very beautiful illustration that why the interatomic forces or the intermolecular forces is the deciding factor for solid, liquid and gas. Now if I ask you that you can put your hand through the gas, okay, if air is present in the atmosphere, you can wave your hand freely. But if you take water and if you try to put hand through it, you will face some resistance, although you will be able to do it, but you will feel some resistance. Now if you take your table and just try to push a hand through it, then it is impossible to do so. I will not say impossible, it is difficult to do so. At some point of time you will apply that much pressure. If it is weak, then it will break and your hand will go through. So that's a different case, but the resistance is high. So why is it happening? Have you thought of it? So the reason is that the particles there are very close to each other. Okay, so if you have to put your hand between this, you have to overcome the interatomic forces. Okay, you have to break the interatomic forces between the particles of solid. So for that force to break, you have to apply high pressure. So if you talk about liquid, that pressure is quite low as compared to solid and negligible in case of gas. So we can say that, okay, that interatomic force between the solid particles must be very high. For that reason you are not able to put your hand through it. And one more thing, so if you want to put your hand through it, there should be space between the particle. Either you create it or either it is present already. So in case of gas, the particles are very far apart, so you can easily move your hand through the gas. But in case of solid, where the interatomic force is very high, you cannot break that force and put your hand through it, and there is not much space to do so. So therefore we can say that the interatomic forces is the highest in solids, moderate in liquid and least in your gas. So one more point I would like to add here is that the interatomic distance between solid is very less, then comes the liquid, then comes the gas. Okay, now we can explain many phenomena on the basis of this moving of particles. Okay, I have said you that in gases these particles move very fastly, yeah, and in case of your solid, it moves at the least speed, while in case of gas the speed is moderate. Now this movement of particle can explain one more phenomena, that is heating. How can we explain it? Say you must have seen that upon lighting of your, say, any flammable object, say kerosene. So if you just if water sorry, if fire touches the kerosene, or if fire comes in contact with kerosene, kerosene easily catches fire. It start firing. Why is it so? Why is it done so? Because the kerosene has a very say flammable particles inside it. Okay. Now, as soon as you provide kinetic energy to it, those kinetic energy make it more obvious to leave the surface of water. Means it is volatile in nature. Volatile means it can be easily converted from liquid to gas. So when this process happens, the kinetic energy changes extensively. Okay, so during this kinetic energy change, some energy is released in the form of heat. So this kind of heating, this flame is nothing but this is movement or agitation of particles fastly, and this agitation, this random agitation is termed as fire. Okay, got it? So this was for today's class. So with this, I end my lecture. Thank you.